Hello guys, welcome back to the Embedded Rust on RISC-V YouTube channel. And in this session, I'm just gonna talk about a few code changes which I have made in the UART in the recent past days. And so if you go to the Git repo and if you watch for the development branch, and I will just run through all the changes I have been making. So for your information, and so this repo is my it's just an experimental repo where I keep um, making changes, and whenever I get time, I would run, test, and develop. So anytime if you take the code, and few things might work, and few things might not work. So, but if you are like me, trying to bring up or run embedded Rust on a RISC-V target, and I'm sure this channel and this would be very useful. So, for example, so in the UART, so there's a serial trait which I have in the serial library, and the serial which I plan to make it common across all the serial device, so that for UART it would call this UART functions. And there are a few important and interesting changes. First one is I have added this function to check if the TX is busy or not. So if you go through the RISC-V manual for the UART, so the MSB bit of the transmit register indicates if the UART transmission is busy or not. So if there is space in the TX34, then this MSB wouldn't be set. However, if there is no space in the TX34, that means that UART is busy and there is no space. So this function I added to check if there is space in FIFO before transmitting the data. So that's one. And the second one, I have added the function to send a byte atomically. As you know that FE310 has a E31 core, which is an RV32IMAC. So 32I and multiply and division M, and A stands for atomicity. So it does support a bunch of atomic instructions. So one among them is the atomic OR on a W on a 32-bit as well as 64-bit. But this is a 32-bit core, so this is a 32 bits atomic OR instructions. Okay, so how is this used in this UART transmission, or how it can be leveraged to check if the data is transmitted or not? That's quite interesting. That's what I would talk about for next few minutes before I jump into the print binary or application, which would use this to transmit data. So the syntax is quite straightforward. So this atomic instructions, this atomic instruction, what it does is it reads the data from the memory address in T0. It will read that into T2 register and perform an OR operation, bitwise OR, with the value in T1. Then it would write back into the memory address, whatever is put in the T0. Okay. So now, so here, these are all GNU assembler code, and you can search how to pass values between a local variable and a register. So for your information, I'm not yet clear, or I don't have a ABI or a binary interface which registers are used when switching from, or which registers of RISC-V are used by Rust across binaries. So ABI part I'm not clear, so I'm assuming that T0 to T1 wouldn't be used because these are temporary registers. So assuming that I'm using this. But once the ABI is clear, then we might need to update this later. When I searched, when I checked with the forum, it seems that the ABI is not yet ready. But if you know anything about the ABI, then please let me know in the comments. Okay. So how now, coming back to how this is leveraged for UART transmission is that, so this Your TX register is a 32-bit register and whatever the byte you want to transmit. Um, okay, this is a memory map register, so you write into the lower byte. Let me open the manual for a minute, then it will be very clear. Okay, so this is the register I'm talking about. So this is the transmit data register. If you see here, so the lowest 8 bits are the data that you want to transmit. That's the data you should write into. And any read on this would uh, always read 0 except the most significant bit, which indicates whether the TX FIFO is full or not. Okay. So now going back to the code, so what this would uh, automatically do is it would read the value from the TX data register, which would be any read would be uh, 0 except the MSB bit, which might be 1 or 0 based on the space in the FIFO. And then whatever the data which I want to transmit, so that has been bitwise AND with this to extract the lowest 8 bits. Then that is odd with the red value, and then it would be returned back into the memory mapped register, which is the TX data register. Now, how is this useful is, so after writing or after transmitting the data, if you want to know if the data has been sent or not, if you just read the value from T2, because the T2, before writing, it would have read the value into T2. And if the most significant bit is 1, that means that there's no space in the FIFO. So whatever you write, it would have been discarded. So that's how this atomic. But if there is no atomic city support, but if you just read the status, and there's always a chance that before you write, then some other date on multi-threaded, or when there are different paths to write into the TX register, that's when this is very useful to know if the data that has been sent or if would have been sent or not. Okay, so that's a brief on this atomic send instructions. This I have added in the UART, and so that's it. These are the so the corresponding changes in the traits. If you go to the serial trait, so send by, so poll tx busy and atomic send. So these are the corresponding functions I have added in the serial trait. And if you go to the print application, then I would be, so now I can show from my local code how those functions are invoked, and let's see what is the how this helps. Okay, so first what I'm trying to transmit is this string, and please be aware that this byte string in Rust, a character, most of you would have known that a character is not always a byte. Honestly, it's a 4 byte, so each character is a 4 byte, and so unless you specify this byte string, it's not going to be 8 bits. Okay, so this is a byte string I'm going to transmit, and this is the best part I like in Rust. For loop, you don't have to I declare an identifier for I and C. You can straight away use it. And uh, first I'm trying to check if if the TX is busy. If it is busy, then I have introduced induced artificial delay of this many, because the UART, which has been set as 115200 baud rate, which is equivalent to the bit rate, is almost 9, close to 9 times. slower than the core clock. So after delay, then it would try again. If it is not busy, then it sends this data, okay? And after sending, so 10 times, 1 to 10. So in Rust, this would be 9 times. So 1 to, so this, yeah, 1 to 10 is 9 times this would be run. And each time this string would be transmitted. Okay, and after once that is done, then I send this end node just to make sure that that's done. So this is sent here, then there's a delay. Then uh, let's see, we'll come back to this atomic send later. First, let's see how this works. So you can see that this has been transmitted 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me see if I can file window. Okay, zoom. No, that doesn't help. Okay. So 9 times this data has been transmitted without any corruption. Okay, so now let's see. I have intentionally added few non-ASCII or non-text characters as well. So now let's see what happens if we use the atomic function. So I would just comment these. So you can see that RSC2 send byte. So the atomic. So if you see this data, so the byte string transmitting with the atomic send function, and I'm sending the end node by checking if it's busy or not. So the end node is transmitted properly. However, the atomic send, if you see here, it's the data sent through this atomic function is not sent properly. So that is because if you see here, so how this works is, so even if it is busy, this atomic function, so the way of writing is that you would know if the data has failed only after it is sent. So when it is busy, if something is sent, then we wouldn't know if the data is mostly it would be dropped. That's why you see here first, as long as there's space in FE4, this particular, sorry, so initial first few bytes have been sent properly because there is enough space in the FIFO at the very first. I have set the FIFO to 7 bytes. So after that, it becomes clobber. Okay. So that's pretty much about it. And I would be slowly uh, working on this to have a proper console output and then move on to the RTC of the FE310. Okay. And thank you. And please click the like button or feel free to subscribe if you are interested in more videos like this. Thank you.